That slide didn't change. I think you still know me from 40 minutes ago. And here, the same thing as before. But that time, we will see how we communicate between the Sensinak part and the AI part. And in fact, afterwards, what we are working on is to have the same thing between the AI and the UI using WebSockets. So, WebSockets, what are they? So it's quite recent. 2011 is not that far behind. So the idea of WebSockets is to have a bidirectional message protocol, a binary protocol, which works as an upgrade of an HTTP connection. We just discussed with Mark the issues it causes with proxies, etc. But when you configure your servers correctly, that works. So you have an HTTP connection, and it's upgraded, which means it changes protocol to become a WebSocket. So it's considered a TCP level protocol, and because once it's upgraded, you have no HTTP anymore there. The idea is to send messages, so either text or binary. UTF-8 is the standard for text communications. And it sends messages. That's what we see as developers. Underneath, in fact, it's split into frames. So you have no limit on messages size, and you have a limit on frames size, which I think we will never attain, I hope. So how does it work? You send an HTTP request to your server, and you just indicate you want to upgrade to WebSocket with some secrets, etc., and a list of sub-protocols you might want as a client. So sub-protocols means I support that version of a chat message, of a notification group, etc. And the server will accept with a 101 status code, which is switching protocols accepted, reminds what we upgraded, and it also indicates what the server uses as protocol. Funny thing in the specification, that could be something that is not present here. So the server will always have the final word on which protocol we use. So after that, if you agree, you continue and you're in WebSockets. If you don't agree, you close the connection and try some other server. So we have four standard events in the specification. Open, it means the connection was opened. Error, something went wrong. Message, it's one data was received, either binary or text. And close, when the WebSocket is closed. Nothing wrong here. Those messages are received both by the server and the client. Because in fact, everything works nearly the same way in both sides. Here you have the JavaScript example in the Mozilla developer network. So that's the first lines of code we'll see. When we go to Java, it's a bit less readable. So WebSockets are defined in the Jakarta specification. So the last one is WebSocket 2.1 for Jakarta E10. And it has a reference implementation, which is EclipseCon, which is the one we will use today to try and get WebSockets into OSGi. So as you see, client side and server side. So the main difference is the fact that you have a server endpoint with a path where you will get some data. The specification indicates, as in servlet specification, that you can have parameters from the URL. I didn't try that in the current prototype of WebSockets in OSGi, but it should be doable. And for the rest, so the specification gives us the events handling methods. And so you can have as many parameters as you want. So the session is what you use to communicate with the client. and then you can ask for the message that was received, the parameters. You can have also some configuration information from the WebSocket, this kind of stuff. Here is an example on how you send data from the client to the server or the server to the client. So again, this is a bidirectional protocol. So you can send data, the client can send data as much as he wants to the server and vice versa. You don't have the the request response model in that case. So how do we use it in SensiNact? So here, for example, we have a small UI of the various buses in New York we detect. We have some data, some properties about them, and we have their location. So to do that, we in fact connect SensiNact in WebSocket. It's accepted. We then list the current position of buses directly, and then we subscribe to them. So if you remember the typed event presentation, so we have we don't need the data part because we know that's that for the subscription, but that's the same way, the same path as we used before. So we register for a subscription. We get an answer from the server that says, okay, I know, I accept your subscription. I give you a subscription ID. And then each time a bus moves, changes speed, etc., we will have a notification message from the server. And we get that as many as we want. The performances depends on your network, obviously, but it can work quite fast. So for the SensiNact thing, so what I just showed you, we did that using the HTTP, the Apache Felix HTTP bundle based on JT. And for the first try, well, we decided to use JT WebSockets. So to do that in SensiNact, we had to extend WebSocket servlet from JT. We had to disable what it does in the init, so it's a JT-specific method. We had to delay the creation of the container of WebSockets. So both squares here are JT-specific code. And here, we delay the initiation here right after having ensured that we have the JT WebSocket container there. And doing that had to wait for the whole servlet to be set up. If we didn't do that, we had locks sometimes or exception afterwards. And another thing is that we had to override the getServlet context used in the servlet request. If we didn't do that, we get a class cast exception inside JT. So far down after Apache Felix. So those two parts were specific to JT. So that's where we said, okay, we have something that works for servlets. So why don't we have the same for WebSockets? So that's what we want to do. We want to have, in a better world, some place where you just say, I have an endpoint with the annotations of the Jakarta standard specification, and just adding annotations similar to what we have in servlets, and hoping that with just that, whatever is your implementation of HTTP underneath, if it supports WebSockets, this would be accepted and serving your endpoint. So our battle plan. So the important part here is Jakarta, servlet and filter. So we want to remove absolutely any code that depends on JT. For the first example, instead of having a highly dynamic whiteboard pattern, we use the greedy static one, which means each time a new service comes or another one goes, we shut down everything and restart the WebSocket container. That's temporary, but we saw that the Taurus must be upgraded to handle that more correctly. We use the Taurus engine container for WebSockets. And the idea is to register a proxy class as endpoint for each WebSocket service we detect. And it will be instantiated by Taurus when a query comes in. And it will find the component we want, or the service that matches our WebSocket endpoint, and use it afterwards. And the most important thing, we want to do to write as less code as we want for that prototype. So we delegate a lot to Taurus. So the first test worked, but what we saw is we still need some JT-specific behavior. Something strange that, so Taurus uses Grizzly, I think, underneath by default, which accepts the normal behavior. You try to upgrade, and then you send the status code to say, OK, it worked or not. In JT, it's the opposite. You need to say it worked before trying to upgrade. That's some specific behavior, but yeah. We will have to check if it works with other implementations of HTTP service. Due to that, we had to rewrite just a small bit, just 10 lines in the Taurus code. The issue is that it accesses Taurus package-only classes, so we had to copy and modify those 3 classes. And with those 3 classes modified just to be working on our prototype, we have something that works, which means we have a WebSocket endpoint detected by our whiteboard pattern and injected registered via a filter and a servlet with Jakarta types only into JT and executed through Taurus servlet engine. So here's what it looks like. So that's my server endpoint. So I have a component. I have a property so that is detected by my whiteboard pattern. I use a Jakarta server endpoint annotation so that I define the path where I want to go. Here we use the prototype service scope, but it could be in a singleton depending on what you implement. And then you have your usual Jakarta annotations and methods. So that's what we dream of. But also, we did that work with the endpoint class. That's the other way the Jakarta specification indicates how you register WebSockets servers. You just indicate that you extend the endpoint class, which has on open, on close, on error. And you have to register your own message on links. And in that case, we just need to add the WebSocket path somewhere to say, well, that's where I want to answer. Yes, there's a bit of code in there. Here is how we find, from the proxy class, how we find the service we wanted. So we use the user properties of the endpoint configuration, which is given by Taurus, and we give it some user properties. So from there, we get a bundle context, because that class, the class calling that is instantiated by Taurus. We get the service ID, and from that, we get a new server instance, and we use it as an endpoint as any WebSocket handler would. That's the same thing for annotations. We just reused the annotated endpoint the class from Taurus to hide everything in terms of reflection, etc., based on annotations. So with that, we just don't care if it's annotated or not. We don't have to do that. The only thing is that we have to run this in a specific class loader, which is the one from Taurus, because it uses Java services to find how to decode and encode the data it received. Just a small animation I did for some reason, because I thought too much code is too much, and I don't have anything else to show. How it works? So that's a component. So it has a spawn instance that provides a servlet and filter. It will be looked after by JT once a query comes in. So the first thing it does is it looks for components and services matching the properties we want, creates and registers the proxy class each time it finds a new path, registers them to the TRS engine so that when you have a query, it calls the upgrade handler, which calls the TRS engine, instantiate a proxy, work with the component, and goes back to the bidirectional communication with your client. Is that okay for now? So, I have a small demo. What we'll do here, we have 5 endpoints, test annotation and annotation proto. So the difference between those two is the fact that one is in scope singleton and the other is in scope prototype. Those ones are exactly the same, it's just that the code is based on extending the endpoint class instead of using annotations. And square is just something annotated, but from another bundle, just to test that it works when you're not in the same bundle as the prototype. So as it should. So behold. So here, like I said, I will connect the prototype version here. Okay, it takes too long. Yeah, it's better if I run it. Okay. Okay, so here I have a first message. It's the on connect of the endpoint that sends me back a welcome message. And here, if I connect it on that side, I see that I have another ID, so which is what we expect. If I send an hello world here, I have an echo. If I send a hello here, I have an echo also. And if I use my send me smileless message, yeah. Sorry. So yeah, that's because there is a timeout a bit. How to say that? The timeout is a bit short in that demo. Okay. And if here I say $, send, I see that the last message I sent is depending on what I sent to that connection and not to the other, because I sent hello after sending hello to, etc. So here we have one instance of the component for each connection. If I want to connect the other one, I put that here and here. So I can connect that one. Here you already see that we have the same ID on both sides. And if I say here, I do $, here, you'll see that they share the same state because it's the same instance behind. And like I said, the square one, which is the most basic endpoint, the square one is just returning you the square value, the square of the value you send it. So for example, here, let's say 14. And you just have that. The only difference from the others is just that it's a new bundle that added that part. Okay. So, tac. Okay. Yeah. So, good news. With what I just showed you, it means that we are able to do the whiteboard pattern for WebSockets. It works, and the code we have doesn't depend on JT. It was quite easy to do. I can show you the code. It's just, yeah, I didn't count it before, but it's less than 200 lines total for all the demo I showed you. And the access to components works as expected because that was also an issue. We weren't sure we would get the right service doing that. Bad news. So dynamicity is not excellent. Like I said, we have to restart the whole container each time we want to add or remove an endpoint. I looked at the code of Tyrus. It had some methods saying you can remove an endpoint directly. In fact, it's again a package private method, and underneath it's not implemented. So here we have two solutions. Maybe we could try to enhance Tyrus and add the removal of WebSockets. Or we could just have one proxy class that does all the work behind. And when the service goes away, we just return a 404. So next steps. So just like I said, that's trying to mitigate the bad news we had. Also, what would be nice would be to add some configuration, avoid having everything under the /WS endpoint. And possibly add some configuration of default timeouts and the incoming buffer size, because like I said, you can have 2 power 63 bytes as income. So that's something you don't want to have a buffer of that size somewhere. So that's some configuration we want to add. And then once we know that works for real, it will be time to write the specification draft, which I didn't start yet. We have the requirements, but nothing else. We'll need to find someone to implement the specification. It would be better if it's someone else that implements the spec, and someone to implement the TCK. That's what we said I think last year, even. So yeah, we will need some help on that part. And obviously, the end is we have to make sure that it works, and we can finally have WebSockets endpoints in just a matter of 10 lines, tens of lines, no more. Okay, thank you.
So if you're just interested in WebSockets, what do you need OSGi for that?
In fact, we use JD for the HTTP part of Sensinact. And as it provides WebSockets, we started with that because the WebSocket whiteboard pattern wasn't even an ID at that time. And it's after some usage that we understood that having a WebSocket endpoint whiteboard pattern would be great, and which is independent of JD.
To move the small hack you did to the Tyrus, it would work on Jetty and on any other.
So that's something to test. That's something to try. Yeah. I think as it's an exception raised by JT as a specific place, we could try to say, okay, we try the normal way, and for JT we try another way afterwards.
Yeah.
That could be a fallback. Yeah.
And the intention is also that this can be used on top of the normal HTTP whiteboard. Get my WebSocket whiteboard registers to the HTTP whiteboard.
Well, we could reuse part of the HTTP whiteboard, I think. We just need to be sure that we have the Tyrus bundle to provide the required.
Because in the end, you just register a servlet somewhere in the container.
Well, it's a servlet, and we use the Tyrus engine afterwards.
Yeah.
So, because it just, in fact, when you look at it, it just, we just call here, we just have to do that, and manage errors. So that in behind is just calling Tyrus service container, which must be active. So if you ensure that it's there, we can do WebSockets.
Yeah, it's just a servlet filter, or no?
Yeah, so it's a filter for the upgrade, and we require to be a servlet. So that was for.
And you already registered
yeah.
On the
Yeah.
HTTP whiteboard. Okay,
Yeah.
that's everything I want to know.
Yeah. And so that's the part we need to configure, because currently we are forced to be under the WS path with that.
Yeah.
Any other question? Was it too much code? Okay then.
Thank you.